Hello, good afternoon. My name is Madrina Chirija, and together with Tohai Sejin, we're going to take you through um, our project. We're going to continue to take you through our project and how far we've gone this time around. And we're going to try to pitch to our ideas so that you can get to know and understand what is actually going on. So, as we've been looking at it, previously, we talked about the problem that we're actually solving, which is one size fits all. And the reason that's why we're actually solving this problem is that we need to address the diverse learning paces. Since everyone learns at a different pace, we need to address the diverse learning styles and to address the knowledge gaps that happen when someone lags behind and they have not been able to learn at the pace as the rest. Well, the objectives that we're actually looking at in this work is to design a generative model that personalizes the learning experience, to enhance student engagement and motivation, to ensure that the platform relies on dynamic data. That is, it's not basically on what it was trained on, and to also neglect biases from the training data. Yeah, that's basically those are basically our objectives, therefore. And to give you a brief solution overview before we actually dive into a bit of the technical bit, uh, this solution it's going to accept input. It's going to have input collection. So when it collects input, it's going to have knowledge graph generation. That's why it tries to create relationships between the different things. And then after creating these relationships, it's going to select the materials it can use. After selecting the materials it can use, it will learn a path. And okay, it will get to learn how you've been progressing, and it will keep this progress so that it can monitor it, and then always give back feedback and recommendations on how best the rest can be carried out. Yes.
Hello everyone. Continuing from where my group members stopped, I'm going to be explaining the data sets that were used, models and the architecture that was used to implement this model. So first of all, in our project, we decided to use the GSM 8K dataset, that is the Grid School Math 8K dataset that contained around 8,000 examples of sample math word problems, which are adapted for elementary school. So basically what we did is we're able to come up with analysis to show the distribution of numeric answers based on the questions that we were able to get from our dataset. Then we're able to process it by extracting key concepts, which can include addition, subtraction, which will help us create graph notes. Then we're able to also improve on the annotated indents, whereby we're able to see the questions which are able to just give us equations or those that are word problems. So first of all, we're able to load the JSON L, that is the format of our data set, JSON line format. Then we're able to clean the data. So here, cleaning the data, that means we're removing unnecessary characters, questions which had missing data in them. Then we're able to split them into trained data sets and test data sets based on a 90 to 10 percentage. Then we're able to tokenize. So for our case, we used a GPT Neo tokenizer. Then from there, to create our model to be ready to be used. Then in case when we to use it in Uganda, we have an original question which has, for example, John has 5 apples. He gives to Mary, how many apples does he have left? Then we can adapt them to our case in Uganda. Mariam has 5,000 Uganda shillings. She spends 2,000 Uganda shillings in base. How much money remains? Then in the models and techniques we are using a graph retrieval augmented generation where we were able to source knowledge from different sources. For example, our data set, then we were able to search relevant information and we enhance its context, and based on the prompt given to us, we were able to access a large language model endpoint to give us a generated text response. Then implementation details here, we were using primarily Python for our coding capabilities. Then libraries, we are using TensorFlow, PyTorch, and scikit-learn, which helps us to generate the models and to use other frameworks like Seaborn, then Pandas and NumPy for data management. Then we're able to host it on Streamlit and keep our code on GitHub and run some of our simulations on Kaggle. Then and the results from our model training, we're able to evaluate the training loss and the evaluation loss. So from this graph, we're able to see as the epochs kept increasing, as time went on, the training loss was, the evaluation loss was increasing and the training loss was reducing. Then we're able to configure the future importance in a particular question. For this example, what is 5 plus 7?
Picking on from where my group mate has stopped, the impact and relevance of this, why we are actually looking at this and saying it's a good idea, is that when we look at Uganda, it's going to help in personalized learning in the large classes. Since the classrooms in Uganda tend to be big in big numbers, it's going to help the bridging the educational gaps. It's going to be okay. It's relevant in a way that there is accessibility and affordability, because instead of someone can fail to pay a tuition of like 1 million, but can buy that of maybe 5,000 and try to keep learning. And then it addresses learning losses where someone is lagging behind. And it aligns with the digital transformation goals in Uganda, where they're trying to adopt AI in their systems. And the SDGs that we align with, there is, the beneficiaries of this idea, it's going to be the elementary education institutions, the teachers, the students, and the parents. Yes. So looking at the intellectual assets, we have machine learning algorithms, adaptive learning processes, the source code, and the fine-tuning processes. And with this, we say that our project is patented. Yes. So last, what I'll talk about is the monetization and the scaling bit. How we look at getting money is through subscriptions, through freemium, where we shall offer some services and give them a prompt of, if you need to access this, pay some money. Then partnerships with other organizations, pay-per-use, where people pay for what they're going to use. Then advertising, since it's an education platform, schools could want to be pushed out. Yes, and then some of our strengths, it's personalized, that's one of the strengths, and it's AI-driven and it's scalable. Then one of our weaknesses, the main one might be it requires internet access, so rural areas might be affected, and the high cost that we need for initial AI training. And the opportunities we have is that there is a growing demand of AI in the education sector. And a threat that could possibly be there is that there is slow adaptation in rural areas and competitors like Khan Academy and Duolingo. Yeah, basically, that's what I had for you. Thank you.
System and the system demonstration. To take you to the system demonstration, we're able to host our thing on Streamlit, whereby we're able to view the different aspects of our model. For example, training statistics, the loss curve, the gradient normal distribution, the training accuracy and learning rate, and other predictions. For example, predictions versus the ground truth. And also, we're able to come up with a FICE query. So a FICE query basically is a Facebook AI simulated search query that helps us compare similarity of questions and help assess a question based on similarity with different word problems out there. So we can just put a question, for example, what is the product of 5 and 15? And when we enter to apply, it will retrieve the question, the top 3 similar questions that we have. So in this example, you can see the top 3 have a similarity index of 0.04. So if the similarity is exactly 0, it means we have the exact question. And as it approaches away from 0 in the positive sense or the negative sense, it means the question is varying. Yeah. So after that, we're able to know the lessons learned. So in our case, we're able to learn various lessons. For example, we were able to understand various methods in machine learning and artificial intelligence, for example, retrieval augmented generation and fine-tuning, and also web scraping and also graph neural networks. Then we were able to see an insight in how to scale this project in use of, for example, how to incorporate complex mathematical insights and questions. Then we're able to localize our fine-tuning in the lessons that we are learning. We're able to find out that we can fine-tune this model based on data from Uganda. The challenges we had in our processing thing was, first of all, our model required extremely high computational requirements like RAM and storage. Most of these models are too big, ranging to almost 40 GB. We weren't to effectively use the online options like Kaggle, which would help us run this model very well. And even the RAM of most of our devices couldn't handle. So most of the results were inaccurate. And then hyper-parameter sensitivity. Most of the parameters in our data sets and the corpus that we're using, they weren't sensitive. They were very insensitive, hence they were giving us underfitting values. Then data limitations in terms of quality and availability. Most of the data sets are ranging within a small aspect. So looking for questions, we have to outsource a large number of sources. For example, in Uganda, we have to look everywhere. So most of our data is a bit limited. Then, and the future works, we're looking at expanding not only English, but also integrate other languages suitable in Uganda, for example, in Swahili. then also to crowdsource math problems within that fit in the Ugandan curriculum. Then also optimize the model for rural schools, for example, using compressed GPT neo graphs, and also increase our model so that we can use them in higher levels of education, not only in elementary, but also primary, secondary, and even tertiary if possible. Yes. So in conclusion, we have developed a system that personalizes the content for education and implemented a method for adjusting the content based on the pace of the student and difficulty. Thank you.